So our second video on our lecture on bonds. Last time we finished up right here, we were talking about some of the optional features that bond contracts may or may not have. Next we're going to move on to bond pricing. We're going to start with kind of the simplest bond there is, which is called a discount bond. It pays with zero coupon rate, so it doesn't make an annual payment. It just makes a principal payment upon the maturity of the bond, which is again usually $1,000 par value. So there's only one cash flow involved. There's one cash outflow involved for the bond issuer, and that's the maturity date, and one cash inflow when they receive their money when they issue the bonds. There is an interest rate, obviously, they pay because usually they have to issue the bond at a deep discount relative to the par value. So if they're issuing a $1,000 bond on their future value, they have to pay $1,000. They might only be able to issue it for $700, $300 less, and then there's an applied interest rate in there. Let's do an example. So how much should you pay for $1,000? So now you're the bond buyer, not the bond issuer. How much should you pay for a $1,000 10-year discount bond if you require a 12% return? I've got our 5 key variables here, which again actually match up to the 5 gray buttons we've talked about in time value money problems. So for example, par value, that's going to be $1,000. And that's future value on our time value money problem, because that's what they'll pay at the end of the life of the bond. Maturity date is in this case 10 years, which is in your time value money problem. The coupon payment is determined from the coupon rate. The coupon rate is 0. It's a discount bond, so this one's easy. It's just 0. Your payment in terms of time value money. Your yield to maturity is the interest rate you're actually going to earn on the bond, which is 12%, and that is your I/Y. And then lastly, price is what you're looking for, so we'll put a question mark there. And then what is that in terms of time value money? That's your present value. And so we've got our 5 gray buttons. They match up with our key components of a bond. So I'm going to switch over to a time value money screen. So here I have the basic layout of a time value money problem. It's just like we did in the last week's lectures. So we have 10 years, $1,000 par, no payment because it's a 0 coupon bond. We want to make a 12% return. We want to know what that price is. And when I plug all that into my calculator, I get negative. It comes out negative because you'd have to pay to buy the bond, $321.97. Oops. Let's just leave it at $322. We'll round. So obviously the bond sells way below par. Why is that? Well, the only way you're going to make any return on this security is through the increase of the price of the bond. The day, let's say it's 1 day till maturity, so it's 9.999 years into the project, into the bond, and you only have 1 day left until it matures. How much is the bond going to sell for? Well, it's going to sell for almost $1,000 because you're buying $1,000 cash flow tomorrow. You're going to pay $999.99 or something like that. But as you go further out and make it longer and longer, you're going to pay less and less so that you get some increase in the value of the bond. And if you go 10 years out at 12% return, you're actually going to pay only $322 to get a $1,000 return. So this is really just a basic time value money solving for a present value problem of $1,000 future value. We've just applied it to a bond problem is all. Now let's move on to what we call coupon bonds, which is a more typical bond. Discount bonds are also sometimes called 0 coupon bonds, and they're becoming more and more popular. We might talk about that in a little bit as to why 0 coupon bonds are kind of preferred to the typical bond or a coupon bond. But they're not the most popular at the moment. Coupon bonds are still the most popular, which is where you make some sort of periodic interest payment. It's actually usually semi-annual, which is you pay an interest payment every 6 months. It's just the typical way bonds have traditionally been set up. It's not always the case. In fact, it goes kind of country by country. In the U.S., it tends to be semi-annual. I've been told in countries like Germany it tends to be annual, things like that. It just depends on the traditions in the particular financial markets. But here's an example. This one's with annual payments, which is easier. We'll do an example in a second with semi-annual payments, but this will be a good starting point. But how much should you pay for a $1,000 10-year bond with a coupon rate of 10% annual payments if you require 12% return? So this is really the same problem we just did, except now it's got a 10% coupon rate instead of a 0% coupon rate. So for starters, what's the par? Again, par is the future value. That's how much the bond's going to pay when it matures, and that again is just $1,000. It's still a $1,000 face value bond. Okay, maturity is still 10 years. Coupon payment now is not 0. This is where it changes. You're going to get 10% of $1,000 per year, which is $100, and it's once a year, so you don't have to divide by payments per year. Just divide by 1. So you're going to get $100 a year. Yield to maturity, again, you'd like to make a 12% return, and then we're going to solve for the price. Once again, par value is future value, maturity date 10 years is N, coupon payments PMT on your calculator, yield to maturity is I/Y, price is present value. So I'm going to go over here and I'm going to change my numbers. The only thing I need to change is payment. I need to make it 100, and then we need to recalculate this present value over here. And when I do that on my calculator, I get negative 887 rounding. So significantly higher number. Why is that? Well, you're not getting all your return through the future value. You're getting a significant portion of your return through the coupon payments, the $100. And so the present value to future value growth doesn't have to be near as high, because not only are you getting the increase from 887 to 1,000, you're also getting $100 10 different times. So when you work the math out, now you're willing to pay 887. We're going to talk about the difference between current yield and capital gains here in just a moment. So we'll leave any further discussion of that until just a second later. Now let's scroll down and basically do the same example, but I want to do it in a more realistic scenario, which is semi-annual payments. You pay every 6 months. So if I go back to my time value of money, again, anytime you change the time periods, these three have to all be the same. So in this one we were in 10 years, payments per year, interest per year. Now we're going to be a number of 6-month periods, payments per 6 months, interest per 6 months. So I'm not even going to fill in this stuff. We'll just do it straight from the time value of money here. So because it's the same problem, all I've done is change it to semi-annual. What's going to happen to N? We used to have 10 years of payments. Now we're going to have 20 6-month periods of payments. Our payment's not going to be $100 a year anymore. It's going to be $50 per 6 month. And our interest is not going to be 12% a year. It's going to be 6% per 6 months. When I plug all this into my calculator, I get a slightly different answer. 885. $2 difference. Not that big a deal. It depends on the size of the bond issue as to whether that's a big deal or not. So most of the time, if you're doing a problem on a test and you forget to do the 6-month period, you'll note that whatever answer, if you'd have put 10, 100, and 12 in here, you would have got an answer pretty close. And my tests are multiple choice, so you look at A, B, C, and D, you find the one that's pretty close. That also works in the real world. If you're just trying to estimate what the bond's worth, you can just say, let's just make everything annual and figure out what the bond's worth. It's going to be fairly close to what it would be worth if we were doing everything semi-annual, or even if you had a monthly payment. Say we had a monthly payment bond. Let's do that example real quick. Let me go back to the normal case. It was 10 years, $100 a year, 12% interest, and that gave us $887. Let's say we had a monthly paying bond here, which is rare, but it could happen. Monthly paying debt instruments are not rare. Take mortgages, for example, but monthly payment bonds are kind of rare. You would multiply N by 12, so that'd get you 120. You would divide the payment by 12 because you want payment per month. 100 divided by 12, it's going to be kind of a fraction. It's going to be $8.33 with the 3 repeating forever. 12 divided by 12 is easy. That's just 1% a month. And then let's go ahead and solve for this. And I'm getting $884 for that. So again, fairly close. We're talking about minor differences when you're talking about small dollar amounts. But if you're talking about large dollar amounts, the differences become more important. So, especially if you're levering up, if you're doing arbitrage work or something like that, pennies matter, and so you're going to want to make sure you know exactly how much it's worth. Alright, next we're going to move on to pricing dynamics. I'm going to go ahead and end this video, and we'll finish up with one more video hopefully.